This video is sponsored by Elastic and the Elastic Contributor program. In this video, we are going to talk about how to query nested objects in Elasticsearch. Just so you know which kind of documents we'll be working with, here's an example document. Each document represents a food recipe. Most of the fields should be pretty self-explanatory, so let me focus on the ingredients field, since that's the one we'll use in this video. This field is an array of objects, each representing an ingredient. These consist of a name along with the amount and unit, such as grams. The amount is an integer, and the unit is one of the values that you see to the right. Both the amount and unit fields are optional and do not exist for all ingredients. Alright, let's head over to Kibana and query the data. I have a bool query prepared in advance. What I want to do is to find recipes containing parmesan with an amount of at least 100. We can see that 6 recipes match our criteria. Let's search for parmesan and go through the recipes one by one. The first ingredient we see doesn't have an amount or units. That's a bit strange, since our query specified that the amount should be at least 100, isn't it? Let's check the other matches. This one does contain an amount, but the value is only 60, which is of course below our requirement of 100. The next one also doesn't contain an amount. And this one also has a value below 100. The same for this one. The last one contains an amount of 175, so we would expect this one to match. In fact, we should only see this recipe within the results, because the others don't match our criteria. So why are they included then? To answer that question, let's first inspect the mapping. Since we didn't add any explicit field mappings before importing our test data, Elasticsearch generated dynamic field mappings for us automatically. If we take a look at the ingredients field, we can see that it was mapped as an object field. We can tell based on the nested properties key, which is an implicit way of specifying the object data type. So the field is mapped as the object data type. Every Elasticsearch field may contain one or more values, so we're essentially dealing with an array of objects in this case. Internally, the values for each object key are grouped together and indexed as an array. Consider the following example. This is not exactly how things are stored, but this is how it works conceptually. What happens if we query one of the fields is that all of the values are searched. This is exactly the reason for the unexpected query results that we just saw. Let's see why the query matches one of the recipes. The match query clause is highlighted in blue. It searches through all of the values and matches if at least one of them contains the term parmesan. That's indeed the case, and so the recipe matches this query clause. The range query is highlighted in red and matches if an amount is greater than or equal to 100. In this case, there are 2 values that satisfy this constraint, being 225 and 450. The important thing here is that these numbers belong to other ingredients that are not parmesan. The query clause searches through all of the field's values, regardless of which object they belong to. Our bool query is essentially asking 2 questions when evaluating this recipe. The first is, does this recipe contain parmesan? Yes, it does. The second one is, does it contain an amount greater than or equal to 100? Yes, it does. That's why the recipe matches, even though the matching values belong to different ingredients. What we meant to do was to ask the question, does this recipe contain an amount of parmesan of at least 100? This all happens because when indexing an array of objects, the relationship between object keys are not maintained, and so we cannot run such a query on the objects. Technically we can, but we just won't get the expected results. To solve this, we need to do two things. Map the ingredients field as the nested data type and use a special query. To do this, we need to reindex the documents into an index that contains the updated mapping. The easiest way is just to delete the recipes index and create it with the desired field mappings, so that's what we'll do. I have the mappings prepared in advance, just so you don't have to watch me type them out. The relevant part here is really just the ingredients field mapping. I could just as well have left out the other fields and let Elasticsearch map them dynamically. We can also leave out the mappings for the subfields or properties and let Elasticsearch map those dynamically as well. All that matters is that we set the type parameter to nested for the field. This instructs Elasticsearch to index the objects in such a way that relationships between object values are maintained, meaning that the objects can be queried independently. Internally, Elasticsearch indexes each nested object as a separate hidden document, a Lucene document to be specific. That's the reason we have to query them in a specific way. So, if a recipe contains 10 ingredients, Elasticsearch will actually index 11 documents, the parent document and a hidden document for each of the 10 ingredients, being the nested objects. Anyway, let's create the index with the new mapping. Before continuing, let's quickly talk about this video's sponsor, namely the Elastic Contributor Program. The purpose of the Contributor Program is to recognize and reward all of the awesome people who contribute to the Elastic community. This encourages and recognizes content creation and knowledge sharing within the Elastic community. By submitting your contributions, you are rewarded with points. At the end of each cycle, the top contributors are rewarded with cool prizes such as Elastic merchandise, free training, certifications, and more. And, best of all, you don't have to be an expert to contribute. Any contribution counts, whether it covers basic, intermediate, or advanced topics. Contributions can be pull requests, answers to technical questions, written content, videos, etc. Pretty much anything goes, so you will definitely find something that works for you. Winning prizes is not the only reason to join the program though. By contributing, you will get a network of support as you get more experience with Elasticsearch and the Elastic Stack. And what better way to stand out to potential employers than to flash an Elastic contributor badge? Those are just some of the benefits of joining the program. Besides, of course, giving back to the community by helping others. Be sure to sign up for the contributor program and start contributing right away. Check out the description below for more information. Thank you to Elastic for sponsoring this video. Now that the mapping is in place, let's index the recipes again. There we go, let's head back to Kibana. Before showing you how we can query nested fields, I want to run our bool query again. This time we didn't get any matches. That's because we cannot query fields of the nested data type like this. While we don't get any errors, this is still better than getting confusing and potentially misleading results. Needless to say though, we do need to pay attention when querying arrays of objects, because it's easy to get fooled, both when a field is mapped with the nested data type and when it isn't. Alright, now it's time to see how we can actually query nested fields. We do that by using a specialized query called nested. Let me begin typing out a new query. First, we need to specify the path to the nested field relative to the root of the document. In this case, that's just going to be ingredients. In our case, the field is at the root level, so we just enter the field name. If the field were nested within another field, we could have used the dot notation that you know from field mappings. Next, we need to specify the search constraints within a parameter named query. Within this object, we simply add a search query that we want to run on the nested objects specified by the path. There's really nothing special about this query, since everything in regards to the nested data type is handled for us automatically. This means that we can simply drop in our existing bool query. Note that even though we specified the ingredients field as the path, we still need to include it within our query by using the dot notation. That's all we need to do, so let's run the query and see what happens. This time we only got a single match. If you remember the previous search results, this is exactly what we expected in the first place. Let's find the Parmesan ingredient and verify that everything looks good. As you can see, the amount is indeed greater than or equal to 100. So that matches the constraints that we specified within our query. By using the nested data type and query, we therefore applied multiple constraints to the same nested object, which is what we set out to do in the first place. Note that even though the nested query defines constraints for the nested objects, the query always returns the root document when the query matches. The last thing I want to briefly talk about is how the nested query handles relevance scoring. In particular, how matching child objects affect the parent document's relevance score. Since each nested object is actually a special kind of document internally, Elasticsearch calculates a relevance score when they match a query. How the parent document's relevance score is calculated can be configured with a parameter named score mode. By default, the average relevance score of matching child objects is used for the parent document. So if 4 nested objects match the nested query, the average of these 4 relevance scores is used. We can also choose to use the minimum or maximum relevance score of the matching child objects, or add them all together and use the sum. Last but not least, we can choose to ignore the child objects in terms of relevance scoring and use a value of 0. There is a bit more to nested objects than this, so let's continue. You just saw how to map and query arrays of objects independently of each other. When using the nested query, it returns the parent document whenever a nested object matches. In our case, it meant that searching for ingredients returned a result set containing recipes, being the root documents. That's how Elasticsearch works in general, and that's fine. But apart from just knowing that a recipe satisfied our criteria, we might also want to know what caused it to do so. In particular, which nested object matched. We can do that by using something called inner hits. Inner hits can be useful for a number of use cases, one of which is highlighting matches. Let's revisit the query from before and see how it works. Enabling inner hits is extremely easy, so all we need to do is add a parameter named inner_hits to the nested query. The value should simply be an empty object, at least when using the default behavior. That's all. Let's run the query and check the results. At the bottom, we can see the inner hits. Let's talk about this additional data that was added. It can be a bit overwhelming at first, so let's go through it step by step. Here is the overall structure of search results, with the actual hits omitted. And here is an example of a hit, being a document along with some metadata. The document itself is available within the _source key, which is also nothing new. So far so good. When specifying the inner hit parameter, a new object is added for an inner hits key as follows. This object contains information about inner hits and is added at the same level as the _source object, i.e. at the root of each hit. Within this inner hits object, an object is added for each field for which we have inner hits. In this example, we searched the nested objects within the ingredients field. By default, the key is named the same as the path specified within the nested query. Within this object, we have a hits object, which has the same structure as the outermost object of the same name. Let's look at the actual hits a bit further down the hierarchy. These hits are the inner hits, being the matching nested objects for the ingredients path. The _nested key contains information about the nested object that was matched. Most interesting is the offset key, which defines the nested object's offset within the parent document's _source objects. You can also think of this as the index within an array, which you may be familiar with from various programming languages. Note that the offset begins at 0. Inner hits are sorted by their relevance scores by default, so the order in which they appear may differ from the one within the document's _source object. The offset therefore tells us where the inner object appears within the _source object. Alright, I know what you're thinking by now. This JSON object is getting out of hand. Yes, I agree with you, it's a bit of a nightmare to look at, but that's just how it is. Fortunately, you will usually interact with search results programmatically, so you won't have to look at it very often. Anyway, here is the JSON object shown with dot notation, which is a bit easier to look at. It's still fairly ridiculous, but hey, don't blame the messenger. Alright, just one thing left to cover. 2 simple parameters. The first one simply enables us to change the key that appears directly within the inner hits object within the results. It defaults to the path specified within the nested query. It's typically not necessary to change it, but it might make sense for complex queries. Why? Because a query might contain multiple nested queries, perhaps contained within a bool query, and these queries may use the same path. So in certain situations, it can make sense to change the name. Or if you just prefer to call it something else, of course. The second parameter enables us to configure how many inner hits we want to be returned for each matching document. By default, up to 3 hits are returned, sorted by relevance scores. In our example, we increased this to include the top 10 inner hits. There are a few more parameters that you can use, but they are not frequently used, and so I won't cover them here. Alright, that's it for inner hits. With the nested query, we can query nested objects independently of each other. That's great for filtering the objects, but sometimes we might want to know why a given object matched the query. That's what we can do with inner hits. Alright, let's finish talking about nested fields for now by talking about a few limitations you should be aware of. I will try not to take up too much of your time, because there is no guarantee that you will end up even using nested fields. First of all, indexing and querying nested fields can be expensive in terms of performance. As you know, Elasticsearch creates an Apache Lucene document for each nested object. If you index 1,000,000 documents, each containing just 10 nested objects, you will end up with 11 million documents. Your index will still show 1,000,000 documents, since the Lucene documents are hidden and handled internally. Naturally, this behavior comes with a cost. Elasticsearch is generally super fast, so unless you're dealing with large amounts of data and query throughput, you probably won't notice any performance penalty though. The more you scale things up, the more likely you are to see degrading performance and run into problems. To reduce the risk of that happening, Elasticsearch provides a couple of safeguards, so let's quickly look at those. The first thing I want to mention is perhaps not a limitation as such. We need to use specialized queries when working with nested fields, but as you saw, the nested query is super flexible and enables us to nest any normal query within it, so it doesn't really limit us in any way. It just requires us to write queries a little differently. There is a limit for how many fields with the nested data type that can be added to an index. It defaults to 50, which should be enough, so it's unlikely that you will ever run into this limit. Should that be the case though, this is a setting that can be increased, provided that you understand that you are probably mapping your documents incorrectly if you need to do this. Another limit is that a document may contain a maximum of 10,000 nested documents. This number is across all nested fields within a document. This limit is in place to help prevent against out-of-memory exceptions, which might otherwise occur. Increasing this limit is possible, but generally not recommended. Suppose that we are running a service similar to Shopify, where we provide web shops for companies. We could then index each web shop into a web shops index. Logically speaking, it would be natural to store the orders for each web shop within an orders field, mapped as a nested field. If we're just looking at the JSON objects, this makes perfect sense. But if we consider the performance implications of storing things like this within Elasticsearch, it surely doesn't make sense. We have two nested fields, the orders field and then a nested lines field. The number of objects between the two fields count towards the 10,000 nested objects limit. It's just a matter of time before a customer hits 10,000 orders. In fact, it's even less, since each order contains at least one order line. This is clearly not a good design. An alternative would be to split the data into two indices, one for web shops and one for orders. This is a much better design, because the limitation of 10,000 nested objects now only applies to the lines field within the orders index. The number of objects within a document doesn't grow over time, because once an order is complete, no new order lines are added to it. And no order is ever going to exceed the limit or even get close to it. So when mapping your documents and deciding to make use of nested fields, just keep this in mind. Is it realistic that a document will ever have thousands of nested objects? If so, it might be worth reconsidering how you map your documents. If you keep these limitations in mind when mapping your documents, then you should be absolutely fine. That's it. I hope you enjoyed this video on nested objects. If you want to learn more about Elasticsearch, check out my Elasticsearch course. The link is in the description.